Okay, hello and good morning. Man, it is Friday again. Imagine that. Okay, well, we're finishing up week 6. Let's take a look at a couple of things. First of all, your test is on Canvas. So you have to take a test, Chapter 6 test, MCR, by Sunday. There's a video. Don't wait till the last minute. Watch the video. Number 2, homework for week 6, third 9 weeks is due by Sunday. Again, don't put it off. Let's take a look here. Well, here you have to find your least common denominator. Remember how I told you to do that? You take the biggest one, and the biggest one here is 6. Does 5 go into 6? No. Double it. Does 5 go into 12? No. Triple it. Does 5 go into 18? No. Go to 4 times 6 is 24. Does 5 go into that? No. Go to 5. 5 times 6 is 30. Does 5 go into that? Yes. Does 6 go into that? Yes. Does 3 go into 30? Yes. That's your least common denominator. So you're trying to make each one of these a 30. So what you want to do, and I'm going to use a different color here, 5 times 6 is going to give you 30. 6 times 5 is going to give you 30. And 3 times 10 is going to give you 30. So you should have 12 over 30 minus 5 over 30 plus 10 over 30. Now that you have your least common denominator, we can combine these. This right here is going to be 22, and minus 5 is 17 over 30. And that's what you should have. So make sure you have 17 over 30. Make sure you understand that. All right, let's keep moving. Next, number 2. This one right here you had yesterday. You're going to multiply everything by 2 to get rid of that 2 down here. So when you multiply by 2, the 2's cancel here. So you're left with a negative 4, 5 minus 3x, and then 2 times 2 is 4. Draw a line. This is a compound inequality. You want to subtract 5 from all 3 sides. And this gives you a negative 1. Then you want to divide everything by a negative. Now remember, when you divide by a negative, you have to change the direction of the inequalities. So these right here are going to change to greater than, like that. So now you're going to get 3, a positive, because you got a double negative, x, and then this is a positive 1/3. Now let's graph this. Here's 0, here's 1. Now, from 0 to 1, you want 1/3, so you got to break this into 3 pieces. 1, 2, 3 pieces, and you're going to keep 1/3. So 1/3 is here, and you should color that in. That represents 1 out of 3 pieces. And x is greater, and so 3 is somewhere over here. So 2 will make 3 over here, and since there's a line under, you want to color that. So it's everything in between here plus these 2 numbers. Make sure you know that. All right, that's what we did yesterday. Let me slide that up a little bit so you can see it. Make sure you understand the concept of a fraction. The bottom number tells you how many spaces you need to divide it up into. The top number tells you how many you keep, 1 out of 3 pieces. All right, let's go on to today's work. Copy all of that down. Absolute value is the distance to 0. So write that down. Distance to 0. Okay, so if you're sitting at negative 5 and you want to get to 0, you still have to go 5 blocks or 5 steps. If you're standing at positive 5, you still have to go 5 steps. So in other words, the absolute value of a negative 5 is still 5. And the absolute value of a positive 5 is still 5. No matter which way, you still have to go 5 blocks. Now, let's take a look here. This one right here is going to be the absolute value is always positive. Even if it's a positive, it's always positive. This one right here is positive. This one right here is positive. This one right here, this part is positive, but you got a negative on the outside, so that would become a negative. This right here is a double negative. There's no absolute value, so that becomes a +7. Make sure you understand the differences between these two. Okay? You have to do the absolute value first, but that negative is going to make it a negative. Well, let's talk about today's work, and that is some of today's work. Well, let's take a look at this one right here. Copy down this problem right here. It's an absolute value problem. You have two possibilities. One is going to be a plus, and one is going to be a minus, because it doesn't matter what you put in there, a plus or a minus. All right, so anyway, you're going to put 3x minus 2 is equal to a +5, and then you're going to put the same thing, but you're going to set it equal to a -5. You're going to work both of these out, and both of them will be your answers. So on this one, you want to add 2. So 5 plus 2 is 7. You want to divide by 3, so you get 7/3. That is an answer. This one you want to add 2, but when you add 2 to a negative, that becomes a -3. And a -3 divided by 3 is a -1. Either one of these is a solution for that problem. So if you plug it in, it should work. Like watch. 3 times -1 is a -3. A -3 minus 2 is a -5. And the absolute value of a -5 is a +5. Either one of these work. If you put this one in, the 3's will cancel and you get 7 minus 2 is 5. All right, anyway, this one works the same way, so copy that one down. The only difference is you must get the absolute value by itself first. So you got to get rid of this. So you're going to have the absolute value of 2/3 x plus 3 is equal to, when you subtract 4, you get 6. Now that you have the absolute value alone, then you can go into your plus and your minus phase. So you're going to have 2/3x plus 3 is equal to a +6, and then on the minus side, you're going to have 2/3x plus 3 is equal to a -6. So you have two possibilities, but you must get the absolute value by itself first. Make sure you know that. This one right here is the absolute value and is equal to a negative number. Well, the absolute value will never be equal to a negative number, so this is no solution. Can't do it. Here's your assignment for today. If you have questions, I want you to ask. All right, don't forget about your test and your homework. Let's move on to geometry, my favorite. Let's take a look at this one. All right, I want you to copy those down. Those two right there. Let's see, copy that down right there, actually. All right, so on today's bell work, first of all, you have a test by Sunday. You have homework due by Sunday, 1 file. If it's more than 1 file this time, you will get a 0. Okay, I'm sorry. Anyway, use Microsoft Lens, or there's something called Scan Genius or Genius Scan or something. All right, anyway, let's take a look here. If you go to the App Store, you can find those. This one says find the pink. The pink is called the arc length. So the distance from here to here is called the arc length. And that formula is going to be the fraction. Well, this is 90 degrees. So A is going to be 90 over 360, which is a whole circle, times pi, and then times the diameter. The diameter here is going to be 2 arms. 5 plus 5 is 10. So I'm going to get my calculator. And so my calculator is around here somewhere. Okay. Don't say it. There it is. Okay. So we're going to multiply all of this and then divide by 360. So clear it out. Press 90 times 3.14 times 10, press equals, divide by 360, and whatever you get is your answer. So it's 7.9 inches from here to here, or feet, whatever you want to make it. Now find the area of the green one. Well, the green one is area, so you're going to do the same fraction, so 90 over 360, because it's a fraction of the whole circle, times pi, 3.14, times the radius squared, because you've got to use the area formula. The radius is 5, so 5 times 5 is 25. So get your calculator. Now this is area, so it's going to be 90. Do all of these first. We had a worksheet on this yesterday. So 90 times 3.14 times 25, press equals, divide by 360, and whatever you get is your answer. So it's going to be 19.6 square inches. And there it is. And that's how you do arc length and area of the sector. All right, make sure you understand that. Okay, if not, the videos are still up there. Just take some time and learn it. All right, copy down these two right here. All right, now hold on to your seat here, because these two are on the EOC as well, and they'll be on your next test. Let's take a look here. Well, to get the blue piece, you want to first take the area of the sector, which is like the ice cream cone, okay, and then minus the triangle. If you take the ice cream cone and you subtract the triangle out of it, you're left with that slither. And that's what we want to find, is this slither. Copy that down. There's the formula. Okay? So we're going to do area of the sector. So put 78 over 360 times pi times the radius squared, because we want area. So 5 times 5 is 25. Okay? All right, so once you do that, and then you want to do minus the triangle. The triangle is 1/2 the base times the height. So we're going to take this triangle out, and we've got to do some work on this, okay? So watch what I do. Drop this down like this. Okay, we know that this is 78 degrees here. We know that this is 5 from here to here, but this is also 5 because it's a radius. So it's an isosceles triangle. So if this is 78 degrees, okay, and we drop an altitude, I'm going to use a different color there. So if we drop an altitude here, it's going to split that 78 in half. But remember, this angle is equal to this angle because it's an isosceles triangle. So let's see what that is. So let's take 180, which is the whole triangle, minus 78, and then divide by 2, because we're going to split it in half. So this one is 51 degrees, and so is this one. All right, so what you want to do at this point is take out one of these little pieces, okay? We need the height, so we're going to put an H here for the height. This is 51 degrees. This is 5. And we need this bottom piece down here, which I'm going to call X. Once you get X, you got to double it to get the whole base from here to here. Okay? All right, so here we go. This is going to be opposite over hypotenuse. So it's going to be the sine of 51 degrees is equal to opposite over hypotenuse. And X is adjacent, so it's going to be the cosine of 51 degrees is equal to adjacent over hypotenuse. Now we're going to go ahead and multiply, so we get 5 times the sine of 51 is equal to the height, H. And then this one is going to be 5 times the cosine of 51, and that's going to be X. But remember, we got to double the X. Okay? So here we want to multiply by 2 to double it. So we're going to use 10, 5 times 2 is 10, times the cosine of 51 degrees. That represents the base. Okay? All right, I need you to understand this one. So let's take a look here. Here's the formula. So it's going to be minus, you're going to end up dividing by 2, okay, 1/2. The base is 10 times the cosine of 51 degrees times the height. Okay, the height here was 5 times the sine of 51 degrees. You have to be able to do trig or you can't work this problem. Let's finish this thing up. So we're going to take 78 times 3.14 times 25, press equals, divide by 360. Now you could do that again just to make sure. I get about 17, so I'm going to have 17 for this part. This whole part I get about 17, and you can write more numbers if you want. Let's do this last part here. So let's take 51 cosine times 10, press equals, okay? And then we want to do times 51 sine times 5, press equals. I get 24, and so here, let me think about this. All right, I'm going to get a negative number here. Now, you shouldn't end up with a negative. So number one, I would double check it. Number two, it's a -7, but my numbers are wrong. So this angle apparently can't have a hypotenuse of 5. It'd have to be much bigger. But the process is correct, okay? You have to first do the cone, which is the area of the sector, minus the triangle. And to do the triangle, you drop the altitude and you figure out your base, and then you do some trig on it to get the height, and then you double it to get the base. All right, let me make sure I divided it by 2 now that I'm thinking about it. I might not have. So let's back up. Let's take cosine of 51 degrees, cosine, times 10, okay, and then times 51 sine times 5, press equals, okay, divide by 2. All right, I forgot to divide by 2. So this does work. Remember to divide by 2. So it should be 17 minus 12.2. It does work. All right, so minus 17, it'll be a negative, but don't worry about it because we'll change it to a plus. I get 4.8. All right, that's a good problem. I had it all set up, and the only thing I forgot to do was divide by 2. So be careful with that. All right, let's talk about today's work. This one right here now is on the EOC as well. This is like if you run around the track. Okay, now here's how you do this one, so pay attention. If you take this part here and put it with this part, you end up with a circle. Plus, this part is called a rectangle. Okay, so this one is pi radius squared, is for area, but we want to go around it, so we don't want to use that. We want to use pi times diameter. So we want to go around this circle, and when you go around that circle, you will end up doing this end cap and that end cap, which together makes a circle when you put them together. This rectangle is just going to be 50 times 100. So here you're going to do 3.14 times the diameter. The diameter of this circle is 50. So you want to put times 50 plus 50 times 100. So if you add that up, you get the answer. And by the way, like I was saying, it is on the EOC. So 3.14 times 50, press equals. I get 157 here. This one right here, I get 50 times 100 is 5,000, I think that is. So I'm going to add 5,000, and whatever I get is my answer. So I get 5157, and this is inches because you're running around, or feet, or yards, or whatever you want to call it. Okay? There it is. All right, let's talk about today's work. There's something called an inscribed angle, and I'm only going to work 2, okay? Or rather, I'm only going to do 10.1. So look up here. First of all, a central angle starts in the middle. The vertex is the center of the circle. That's called central. Copy that down. An inscribed angle, the vertex is on the circle. This is called inscribed. Now, I'm not going to do this one today. I thought about it, but I changed my mind. Draw these 2 diagrams here. Okay, watch and listen. Every diameter is half a circle. So from here through the center and to the circle is called a diameter. So that's 180 degrees. So you always look for the diameter. All right, let's see if we can figure this out. Well, they want me to find arc A. Let me use a different color. They want me to find arc A from here, B to here to D. So they want me to find the degrees from there to there. Well, let me think about this. We know that this is a diameter, so that's 180. So we have from here to here is 180. And then we have to add up these two right here. Now, I'm thinking that there's not enough information because this one would have to be equal to this one. All right, it'd have to be 100 degrees because 180 minus 80 is 100. So this one would have to be 50 and 50, provided they're equal. So to get this arc, the measure of the arc, you would add up 180 plus 50 plus 80. So 180 plus 50 plus 80. Okay, it's not the whole circle. It's basically subtracting 50 from 360. So if you take the whole circle minus that 50, you get 310 degrees, and that's what that should be. Okay, look at this next one here. This next one, you have a diameter. Okay, pay attention. You have a diameter from here to here, and that's 180. Okay, so you're going to take 180 minus 140. So 180 minus 140 is going to make this one 40 degrees. Now, this angle here is vertical to this one, so put 40 degrees. If it's a central angle, the angle and the arc are equal. So put 40 is equal to 6x minus 8, and then work this out. I'm going to say it again. If it's vertical, you get this one, and then central angle, the angle from here to here is equal to the arc. The angle and the arc are the same. So you would add 8 to both sides and get 48 is equal to 6x, and then you would divide by 6, and you would get x equals 8. Now, if you want to find this arc, you would go ahead and plug it in. 6 times 8 is 48, minus 8 gives you 40. Okay, there it is. There's x. And that's what we're doing today, is only side 1 of this worksheet. Okay, so write that down so I don't figure it out and try to charge you. So here's your assignment. It's a little small because I wanted to get both pages on there. So I want side 1 only today. And this is called central angles. All right, so go ahead and get started. Let me pass out these worksheets. Have a good day. I'll show you the answers at the end of the period.